So coming back to the f3ast 3D printing algorithm, we were describing the Febit modeling. Let's see now how we can fit the model through this two-step calibration process. The first calibration consists on calculating measuring experimentally the growth rates. And also if we have heating, our calibration step will also take this into account. These are experiments described in our original publication, which were done for this precursor, which is typically used in Febit, the platinum precursor that we call, at these conditions, 30 kilovolts and 21 picoampere. So what we do is, in this first experiment, this is something provided directly by f3ast. You will see this in other videos recorded by Luca. We grow different wires under spot deposition. The beam is always in the same place. And we grow them for different times, and we measure their height. So this is as simple as measuring their length. This is something that f3ast also does automatically as a function of the deposition time. If we were in the reaction rate limited, which is the regime, which is the ideal for 3D printing, we would obtain a direct linear relationship. So we would have a constant growth rate. But because we are in the desorption-dominated regime, we have a sublinear dependence where the higher deposition times involve higher heating. This is something that our model is going to take into account in both cases. If we are in the reaction rate limited, as I said, the growth rate will be constant, so the height will be directly proportional to the deposition time, and the S of R function, the first part, will be only the growth rate at the substrate. If we have a different regime, the desorption-dominated regime, the expression gets a bit more complicated. I will not go into all the details, but it's logarithmic. And as a consequence, the function S of R is not only proportional to the growth rate at the substrate point, but we also need to take into account an exponential decrease in the growth rate, which depends on the thermal resistance of the structure. This is something that is calculated directly by f3ast. Taking into account its geometry, and also this K factor giving account for the desorption due to heating. More details in the publication. Let's go now to the second calibration step, where we measure experimentally the interaction volume. So what we do is first we grow a single pixel line at an angle with respect to the substrate. And afterwards, we grow the same type of structure, but now is white. And the algorithm assumes different sigma, where sigma is basically the effective single spot width of the deposits, assuming a Gaussian form. We could do it with different functions, but typically a Gaussian works well. So we grow these different wires with different possible sigma values, and then we find for which white wire we have the angle closer to the single pixel line. In this case, it's 44 degrees for the single pixel line. Therefore, at the moment where I had sigma close to 4 nanometers, I had a good agreement in terms of angle. This means that I am therefore effectively taking into account well the interaction volume of the Febit process, and therefore I can start to fabricate more complex 3D geometries. So in summary, this is the two expressions that I will have for the height as a function of time and its dependence with the coordinates in the space. If I am in the reaction rate limited, which is the ideal case for 3D printing, the height will be equal to the growth rate, which will be constant, times this Gaussian, taking into account sigma, and always proportional to the time. But if we are in the desorption-dominated regime, which may happen in Febit because of the low thermal conductivity of the deposits, I will have also beam heating, and therefore the height is not only proportional to the two factors that also take place in the reaction rate limited, but I also have this exponential decay that once more depends on the thermal resistance and this factor K that is effectively taking into account the heating due to the beam. This thermal resistance is automatically calculated for each structure by f3ast, and this will be discussed in more detail in a different tutorial video.